All right, are you ready? We are going to talk about a very special element in organic chemistry, carbon. Basically the focus. So courses and courses and courses about organic chemistry, and we're shrinking it down to a small unit. Are you ready? Okay, so organic means it contains carbon, but specifically carbon bonded to hydrogen. Okay, and this forms the basic of literally living things. It's carbon-based compounds that form our DNA, sugar, methane, ethanol, carbohydrates, proteins, lipids. Okay, organic. If it is inorganic, it doesn't contain carbon. So base requirement contains carbon, but then it's got to be carbon bonded to hydrogen. So there are a few exceptions. So let's look right here. Carbon dioxide, also carbon monoxide. They do contain carbon, but not bonded to hydrogen. So these are called inorganic. So let me write that. It's organic, but inorganic. See how it's written? Inorganic. So remember, carbon dioxide, even though I know sounds confusing at first, it starts with carbon, but it is not organic. To be organic, it needs carbon, but also bonded to hydrogen. Okay. All right, so literally, why am I so hung up on carbon? Like, why is it so special? Well, one, carbon has 4 valence electrons. Why does that even make it special? Well, that means it can form up to 4 single bonds and form a variety of compounds. Brilliant. Carbon bonds are very strong. So even a single covalent bond between 2 carbons is very strong. Strong. In comparison, H2O2, which is hydrogen peroxide, it has a bond between 2 oxygens, and this decomposes at room temperature. Okay, so carbon bonds, so strong. There's hydrogen peroxide. Carbon compounds are not very reactive under ordinary conditions. That kind of ties to what I just said. Okay, they tend to be stable under normal conditions, meaning room temperature conditions-ish. Okay, carbon tends to be stable when it's in compounds. So what else makes carbon so special? Okay, because quite honestly, maybe you're not that impressed yet. Okay, so remember carbon forms 4 bonds, and it talks about that like it was so special. Well, those bonds don't have to all be single bonds, although they can be. What has to happen is the total bonds have to add up to 4. Let me show you what I mean. So here's an example. So let's look at this. Let's have this color. So here's this carbon atom. So we're looking here. So do you see this line that's separating? I'm going to look around this carbon and I see 1, 2, 3, 4 bonds. Okay. Let's look at this carbon, right? So this one right here. How many bonds do you see? 1, 2, 3, 4. That's what it should be, right? So let's look at this example right here. Okay. This one's already done for you. So let's look at this carbon on this side. This carbon. Let's count the bonds around it. Let's switch colors. 1 bond, 2 bonds, 3 bonds, 4 bonds. Okay, let's do the last one. Let's look at this carbon right here. So let's switch colors. 1 bond, 2 bonds, 3 bonds, 4 bonds. We're going to see 4 around every carbon or it's not drawn correctly. So if I had this compound and I had H's right here, right? This would be incorrect. Why? 1 bond, 2 bonds, only 3. Okay. 4 bonds around carbon, 4 bonds. How is this one 4? 1, oops, that's a bad color to pick. 1 bond, 2 bonds, 3 bonds, 4 bonds. This one, 1 bond, 2 bonds, 3 bonds, 4 bonds. Okay. So carbon can form single bonds, double bonds, or triple bonds. Single bonds look like this, single line. Double bonds look like this, 2 lines. Triple bonds look like this, 3 lines. So those 3 lines, those 2 lines, this one's a little neater to look at, count for both of the carbons. These 3 lines count for both of the carbons. So when I count the bonds around this carbon right here, I count 1, 2, 3, and then 4. When I do this one, I do 1, 2, 3, and then 4. Okay. So each bond is one pair of shared electrons, or 2 electrons. So it's 2 total or 1 pair. So here we go. We have 2 hydrogens. I look at this bond right here. It is 2 electrons or 1 pair. Look at this bond between nitrogens. 6 electrons or 3 pairs, 3 bonds. So if it's written in lines like this, those are pairs. If it's written in dots, those are electrons. If you need to get the dots from lines, each line is 2 electrons. Okay, oops, that was kind of really messy. Let me erase that. Let's just do this. So 2, 4, 6, if I have to count individual electrons. So again, a single bond has 2 electrons. A double bond would have 4 electrons, or 2 pairs. A triple bond has 6 electrons, or 3 pairs. Okay. Something else about carbon, it can form short chains, it can form long chains like DNA. Oh my gosh, that's so long. And it can form rings. Okay. So short chains, long chains, rings. Carbon can form, ready? Straight chains, really long ones. It can form branch chains where you got stuff coming off in all these directions. It can form complex 3D structures. Oh my gosh. Also, carbon has many allotropes. Now, an allotrope is the same element with different structure and therefore different properties. So most common you should know about carbon, diamond, and graphite. Obviously, these are ridiculously different. Carbon's strongest material. Graphite is used in pencil. You know, you write with it, okay? But those aren't the only forms, the only allotropes of carbon. There are lots more different allotropes of carbon. So carbon, widely useful. It's the basis of life, remember? Basis of organic chemistry when you have carbon bonded with hydrogen. And there you go. That's carbon. I hope you learned something new today.